BDR FHIR automates and encrypts HL7 and healthcare info. FHIR allows current HL7 applications and new FHIR apps to coexist. Our secure FHIR portal views and extracts encrypted FHIR data for downloads and transmission to patients or authorized users. Use BDR's decryption API with new or existing apps for end-to-end encryption and FHIR data usability. Meet required CMS data standards for Medicare Advantage organizations, Medicaid programs, and qualified health plans in the federally facilitated marketplace. Our app encrypts FHIR data, provides a GUI for access, and downloads encrypted FHIR data with an accompanying decryption app. Here we are seeing 3 levels of security to enter the BDR application. First, the patient or user must have valid credentials into the BDR application. If successful, the patient or user is prompted to acquire a 2-factor authentication code from Google's Authentication application. This code is updated and changes every 30 seconds. If a successful 2-factor Google code is entered, then the patient or user is allowed access to the BDR FHIR application to begin their selection, viewing and if desired downloading of encrypted secured data. Now the patient or user may start processes with the BDR application. Now the BDR administrator will be refreshing the FHIR resources and data elements from the current release of FHIR being used. The administrator is prompted for a second validation as this will refresh all resources and data elements currently in use. Now that the Create FHIR Resources and Resource Data Element process has completed, usually in just seconds, we are viewing a few of the around 150 resources in their data elements. Editing of the metadata for the users and patients' viewing is allowed by the administrator. Administrators and users with proper security authentication may add additional values for display and metadata to the resources of their choice, though these data elements will not be part of the FHIR APIs or processing. Here either a patient, healthcare provider or user with authority may connect to the FHIR database, enter in enough patient information to narrow the results to a single record without disclosing any other patient's private data. Once the single patient is found, then the patient or user starts to select the data elements from the FHIR resources that they are interested in viewing, and potentially downloading for viewing or migrating to another data source, such as a data lake for additional analytics. After the selection of resources and their data elements desired, the process is run to achieve the desired results. Here we see the expected results of the selected FHIR resource data elements we check the boxes to be run for. Now the user selects the download icon. This pops up a box for the patient or user to enter a password for the zip file to be unzipped and a separate password to execute the BDR decryption application to view the encrypted, downloaded FHIR data. Now the patient or user is copying the zip file to a new area to be unzipped to run the decrypt BDR application to have unencrypted access to the FHIR downloaded data. Now the patient or user is opening the zip file and, as expected, prompted for the zip password they entered in the earlier download step. Now, as the patient or user opens the downloaded FHIR data, we see the data was securely, safely downloaded in an AES 256 format. Now we see as the patient or user clicks on the BDR decryption program, they are prompted for the password they used in the earlier process. We will see later what happens if the wrong value is entered. Now as we view the FHIR data, it is decrypted and able to be read successfully by the patient or the user. As briefly discussed earlier, we are showing the patient or user or even a hacker attempting to execute the BDR decryption program over 3 attempts to convert the encrypted data to viewable data, and after 3 attempts are prompted to start the entire process over for security and regulatory protections. Here we want you to see that through all these processes all the FHIR data in the FHIR database has maintained its secure encryption and stays unreadable with double encryption hidden master keys. Lastly, I am drilling deep into the code behind the BDR FHIR application. I am drilling down to the class code that hackers normally find access to and can easily reverse engineer the class code and figure out companies' coding and other trade secrets and personal information. BDR has encrypted its class code so no one can reverse engineer this code and find any personal and secret information. Add BDR's multi-factor authentication using Google's app, AES 256 Encryption of FHIR Data, class code encryption to prevent hackers from re-engineering code to discover secure information. BDR FHIR protects data for CCPA, HIPAA, GDPR and most data regulatory requirements. BDR's FHIR app delivers in weeks, not years. Your HL7 apps continue delivery. BDR 847-440-4439